Okay, folks, we've learned how to do stoichiometry. We can convert from grams of one substance to grams of another substance. Why is this useful? Why do we have to use this in the real world? Why is this important? Let's do a thought exercise first. Let's say you need to make some sandwiches and you've got 4 slices of bread and a whole jar of peanut butter and a half a jar of jelly. How many sandwiches can you make? Hopefully you realize you can only make 2 sandwiches. You've got 4 slices of bread, so you can only make 2 sandwiches. The bread is holding you back. You've got plenty of peanut butter. If you had more bread, you could make more sandwiches. You've got plenty of jelly. It's the bread that's holding you back in this example. Bread is what we call a limiting reactant. It holds us back. It determines the amount of product we can actually make. In this example, we have 2 excess reactants. We've got peanut butter and jelly left over after we make our 2 peanut butter and jelly sandwiches. So the excess reactants do not hold you back. They don't limit the amount of product you can make. So today we're going to learn about the difference between limiting and excess reactants. So let me give you some official definitions for these vocabulary words. The limiting reactant is the chemical that is completely used up in a chemical reaction. It's the reactant that's completely used up. It limits how much product you can form, like the bread in our bread example. The excess reactant, on the other hand, is left over at the end of a reaction. In the real world, this excess is added on purpose. So this is where the relationship to baking breaks down. But the excess is added on purpose to make sure that the limiting reactant is completely used up. And this is done because usually the excess reactant is cheaper or easier to recycle than the limiting reactant. You want to make sure that that expensive limiting reactant gets totally used up. So you add in extra of the cheap chemical to make sure that that happens. All right, so let's do an example of this involving chemistry instead of sandwiches. If we allow 10 moles of hydrogen gas and 7 moles of oxygen gas to react to form water, I want to know what the limiting reactant and the excess reactant are. But the first step is going to be to determine what the balanced equation is, and we're going to determine the limiting and excess reactants by drawing a model so that we can see how many moles of water can actually be made from this example. Here we've got our balanced equation. 2 hydrogen molecules plus 1 oxygen molecule will make 2 molecules of water. So let's draw a picture to represent 10 moles of hydrogen and 7 moles of oxygen. Here I've got 10 moles of hydrogen represented by these white circles and 7 moles of oxygen represented by the bigger red circles. Notice that because hydrogen is a diatomic element, we draw the white circles paired together to show this molecule of hydrogen. And similarly with oxygen, because oxygen is a diatomic element, that also each atom of oxygen is a circle, but the oxygen molecule is made up of 2 oxygen atoms. If I'm forming molecules of water, one molecule of water is 1 oxygen atom with 2 hydrogen atoms attached to it. So I want to determine how many moles of water can I make here. Well, if I use 1 oxygen, I need 2 hydrogens. 1 oxygen, 2 hydrogens. 1 oxygen, 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen, 2 hydrogens. 1 oxygen, 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen, 2 hydrogens. I was able to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 molecules of water, but I have untouched 2 molecules of oxygen gas. My oxygen gas, I've got some left over, so I need to draw it at the end. It can't disappear. I need to account for it, so I'm drawing those extra 2 molecules of oxygen. But what I want you to notice here is we ran out of hydrogen first. Ran out of hydrogen. Therefore, hydrogen was our limiting reactant. Hydrogen was our limiting reactant. Which reactant was in excess? It was this oxygen that we had left over. We have drawn this model to represent, to justify our statement about which was the limiting reactant and which was the excess reactant. And we can also use our picture and count to see that we've got 10 molecules of water forming, or 10 moles of water forming. So this is how you do limiting reactant type problems, or explain limiting reactant problems using a model. And this is the standard that Knox County and the state of Tennessee want you to know, how to use a model to show, to demonstrate limiting reactants and excess reactants. So it's your turn to try. If 3 moles of nitrogen are mixed with 6 moles of hydrogen to form nitrogen trihydride, think of what's the balanced equation, what's the limiting reactant, what's the excess reactant, and show that by drawing a complete model. Your final question is to answer how many moles of nitrogen trihydride can actually form. Pause the video and write the balanced equation, and then unpause to check your answer. Here's the correctly balanced equation for this reaction. Nitrogen is reacting with hydrogen to form nitrogen trihydride. What I'd like for you to do is just pay attention. Nitrogen is a diatomic element, so you're going to have to draw nitrogen as being 2 atoms joined together. And hydrogen is also a diatomic element, so you're going to have to draw that as being 2 atoms drawn together. The ammonium molecule, or the nitrogen trihydride molecule, is going to have 1 nitrogen with 3 hydrogens attached to it. So when you pause the video to draw your model, make sure that you represent your molecules in this way. Pause the video and give it a go. All right. The balanced, if I start with 3 moles of nitrogen and 6 moles of hydrogen, and I draw it like this, then I can form 1 with 1, 2, 3, 1 with 1, 2, 3, 1 with 1, 2, 3, 1 with 1, 2, 3. I can create 4 moles of ammonia atoms, and I have left over 1 nitrogen atom, 1 nitrogen molecule. So I need to write that. It can't just disappear. It's here in my products as a leftover. And I can answer the rest of my questions now. The limiting reagent is the one that we ran out of first, and that was the hydrogen. The one that was in excess was the one that we had left over at the end. That was nitrogen. And I showed that I could form 4 molecules of the nitrogen trihydride, and that's my answer to that question. I hope this helps.